Yeah, and we're going to, we actually love TOTE because it's a great intersection of research, education, management, and conservation. And it's kind of what the reserve system is built on, so I absolutely love it. And I got bribed by lunch, free food, free lunch to do this talk. So we'll be intermixed mostly around lunch and the fun field activities. We're going to go on the kayak trip, talk about Anna's research in a seagrass meadow, probably jump into the salt marsh tomorrow afternoon as well, talk about some research there. But this talk is going to focus on water quality. And yeah, so I'm going to jump right into it. We have a system-wide monitoring program, SWAMP, very forgettable acronym, but it's basically just two components. It's system-wide, so we do it across our 29 estuaries across the entire country, even Alaska, and it's heavily, lots of reserves on the eastern seaboard. So that's the SW part of it. And the MP, the monitoring program, is kind of focused on long-term estuarine monitoring. So just tracking the health of the bay in terms of water quality, weather, and habitats. So I'm going to focus on water quality and weather. Habitats will be something that we're going to talk about really on Friday. So for water quality, we have these data sondes. We have a newer model here on the ground, which we'll play with a little bit later. And they basically are measuring parameters in the water column from temperature to pH to turbidity, gesundheit. And then we also have a weather station. And the weather station is really to kind of vet and QA and really just help us understand any anomalous data or any like really crazy data of the water quality. So we're more interested in the water quality and less than temperature because NOAA, National Weather Service, has got these weather stations across the country. And this is kind of like a pared down version of it, but very local and very helpful. And the last category is nutrients. So we go on a boat and sample on a monthly basis and grab liters of water and run through our nutrients for nitrogen, phosphorus, and other correlates like total suspended sediments and chlorophyll. So that's just kind of an overview of what we're kind of measuring. And where do we measure? Well, all the green dots are our water quality, long-term water quality stations. And I would say what Corey mentioned is PrEP and our coastal program and our towns are enhance this infrastructure to probably like 12 stations across the bay. So you can add more dots there strategically around the bay. We have a weather station, which is this green triangle, and then we have our long-term salt marsh sites, which is over here, and one of them is actually on the boardwalk, which I think you guys are going to walk to soon. And I would say we've been doing this for several decades, since 1995. Our data sondes, listing over here, tracks water quality parameters at a 15-minute interval throughout the year, except in the winter we get iced out, which is a little bit dangerous. Even there's not much boat traffic out there, so we just kind of ice out from January through April. And then for weather, or for nutrients, it's the same thing. We grab water from, except for that winter period. And the weather station is up year round. If you saw that snow picture, I'm a big snow fan, so that's another impact of climate change. Yes?
I was just curious if you guys work together with UNH and their monitoring systems and compare data.
Yeah, we absolutely do. That's a great question. So we actually have a couple of research scientists at Jackson Lab that are doing the water quality monitoring for Swamp and for all those other stations that I mentioned. So it's one big collaborative. So that all the methods are almost exactly identical, and all the data is kind of stored in the same spot too. Great question. Yeah, so weather's done all year at 15-minute intervals as well. And I think that's all I kind of wanted to mention on this slide. So why do we monitor? First and foremost, we're trying to really track the health of the estuary in terms of the long arc of time. Like, what are some impacts? Maybe human development, as Corey's mentioned, climate change. These are longer term impacts. It's more episodic impacts like a hurricane or a Mother's Day flood, oil spill, and we can track those as well. It has implications towards management. We have our habitats that are declining, and it's important to know why they're declining and how we can improve it. So for eelgrass beds, light is a big issue. We've lost about half of our eelgrass beds over the last 20 years. For oyster reefs, we probably lost closer to 90% of our oyster reefs. And in salt marshes, we're predicted to lose a lot of our salt marshes as sea level rise in the future. So there's a lot of implications for management, and water quality is one data set that is important to look at for these habitats, especially the subtile habitats. For research, I did want to mention research begets research. So if you have a research and monitoring infrastructure in an estuary, which the reserve system is designed for, then it can help expand more research. If you go to an estuary that has no monitoring, it's going to be harder to develop a research project or a monitoring plan because you're starting from scratch. But if you're starting at a reserve system, you're leveraging the data, you're leveraging all the other research that's done project here, so you can build, and build. So jumping into some examples, the seagrass meadow, water quality is an important thing. One of the most important things for seagrass meadows is what? For growth and survival? Sunlight, perfect, yeah. So if we reduce sunlight, then we have issues. What are some things that reduce sunlight in a seagrass meadow? Particulates in the water, so like suspended sediments, yeah. Anything else? I feel like a teacher. Well, you can have phytoplankton, you can have macroalgae, you can have epiphytes, which are basically just algae that covers onto the plant leaves. You can have something called CDOM, which is basically tea. If you have too much tea in the water, so all the fresh water, stained water coming in from all this leaf saturated in there. So there's a whole bunch of things, but if you reduce it, it's an issue. This is a graph here. Turbidity is on the vertical axis, and the higher turbidity, the less light penetrates to the water. And you can see the Swampscott is very high in turbidity, and I've been out there a lot. It's hard to see. I filter through the water, and it takes forever. So that tracks. And then you can see it's been an arc of time where it's actually increasing over time as well. So it might be correlated to our seagrass decline. Yep. Yeah, I am, and I'm hoping that this video here will go on YouTube and be okay too, as long as I'm not blocking it. I gotta stop getting so close. Another example is water quality. So as Corey and Kelly mentioned with temperature is an issue, especially fish. You get above high 70s, you get mortality, especially with sensitive species, with sensitive life stages. Larval, fish, eggs are even more sensitive to temperature changes. Another thing would be oxygen. This is kind of a little bit of a tricky graph, but on the vertical axis is kind of showing you the amount of low oxygen days in the summer. And low oxygen is less than 5 milligrams per liter. And it's kind of all over the place. I would say the take-home message here is that Great Bay is this black on the bottom, and it's in the middle of the bay. It's a deep water flush system, so there's always a lot of oxygen. In these tributaries, it's kind of all over the place. It can correspond a little to 2006, which was a big event in 2006, everyone remembers. Mother's Day, flood. Yeah, I always associate Mother's Day with flooding. It was a big event that really shaped the bay in a negative way. Jumping to Texas, Gulf of Mexico, we have a reserve there, Mission Aransas. Hurricane Harvey was that, 3, 4, 5 years ago? Record rainfall, 60 inches in a couple of days. That translates to some big snow person, a skier. Translate to what? Can't remember.
Is it a 12-foot inch?
Yeah, on average about 12 feet an inch. Yeah, so we're talking 60 inches of rain, so we're talking 70 feet almost of snow, which everyone was terrified, but I'm that's a dream for me. So that's an incredible amount of water. So what did it do? Well, it's an incredible storm too, and we have stations in the bay here set through, or they do, and you can see this is wind speed on the vertical axis over time. You can see just maxed out at 100, and the barometric pressure just completely dipped, and that all makes sense. And why did it stop? Well, they actually knocked down our weather station, unfortunately. So it was a pretty powerful storm. This is an interesting one. If you go a little bit east into Alabama, Weeks Bay, Kelly taught me about this in my first year here. But basically, people will yell fish jubilee, and people run to the estuary shore and then grab some fish that are on the side of the shore and some crabs that are barely alive. And what happens is there's a strange event. There's a low oxygen event in the deep waters, and it upwells in the summer, and it can get driven into the shore by wind and tides. And basically, it's like a barrier of no oxygen. So if there was no air over here, and it's just going to get pushed that way. That's the same thing with fish. They're just getting driven towards shore, and It's kind of, the process is all this organic matter going into the estuary kind of settles into the bottom of this deep water, and that feeds all this microbial activity. And in the summertime, when the temperatures are warmer, it holds less oxygen in warmer temperature. And then at like night, there's no photosynthesis, and the oxygen just declines until the morning, and then you get this like perfect storm of low oxygen vent, which drives it to the shore, and you get something that produces maybe hopefully the most interesting part of my talk, which is a video. If I can get it to play. Which computer am I using? This one. It's not loading. But if you were to imagine a bunch of fish basically just jumping out of the water on shore.
Sometimes people out of the presentation. Yeah, sorry. Sometimes it's there.
This something. Okay, unfortunate. It's a little unfortunate, but we can just use our imaginations there. We can dance interpret it later. But anyways, there's just these fish that are just like jumping out of the shore, and it's just slim pickings. Usually they survive because it's a short-lived event, because during the day then photosynthesis kicks in, there's more oxygen in, and then tide comes in. The only way they really die is when people kind of like grab them, and dogs kind of grab them, like in this previous picture. So, jumping into the data, this is actually Weeks Bay in Alabama, and there's a station right in the middle. This contraption here, and this is kind of a complicated graph, but it's showing you dissolved oxygen on this vertical axis, and the screen is kind of your threshold or your better water quality, better oxygen. The middle is very, very marginal, and this is just terrible. And then this August 20th, you can see basically it's below 1 milligrams per liter for a couple of days, and that led to this fish jubilee event. Jumping into weather and jumping into a national perspective, this is kind of cool, not really researchy, just interesting. There's a total eclipse in 2017. I wasn't able to look at it directly, but I projected it on a binocular. It's not super interesting. Not as interesting as the crescent eclipse, which I saw on the boardwalk a couple months ago. It was gorgeous, by the way. These are light graphs, basically, PAR graphs, photosynthetic active radiation, and this is the day before the eclipse, this is the day during the eclipse, this is Alaska going all the way to the east coast, and a typical day without any clouds looks like this. This is kind of nighttime, dawn, high noon, dusk, nighttime again, with no clouds, and there's a lot of clouds throughout the country here, so that's a little bit interrupted. And you look here, you can kind of see like this dip that kind of like permeates across the daytime, across America, and that's the solar eclipse. So I thought that was really interesting. Bringing it back home from my last example, this is Great Bay. We talked about the Mother's Day flood in 2006. This is just south of Newmarket, so it's very flooded, obviously human impact. What are the bay impacts? This is again a rain graph. It's in millimeters, so we have to do even more conversions. Instead of inches to feet, we're doing millimeters to inches, but it's basically about 300 millimeters over a couple days, which is about 4 inches equals 100 millimeters, so it's about 12 inches of rain. Not nearly as impressive as Hurricane Harvey, it's still a huge impact. So what did that do to our bay? Well, this green line is salinity, and this is the scale here on the right, and it drops to 0 for a week, which is pretty much unprecedented, and it had a huge impact on our oysters, on our seagrasses, and on our fish communities. And the oyster population hasn't even recovered since then. It's been, 15 years. Other impacts from the storm is high turbidity and a couple of spikes here. We also have a drop in pH. Ocean water is a lot more basic than fresh water. And that's kind of it. I did want to jump into how to get the data, and you can jump on a boat with Kelly and I and grab it, or you can go to our website, and hopefully this works. So we have this nice website. I was gonna like navigate through it. How do you get a presentation mode? Okay. Technology. Did I break it?
No.
Alright. Alright. It's a lot easier on my computer, sorry. Open hyperlink. Oh, really? Okay, so sorry about that delay. There's definitely a lot of different ways to access the data. If you want to access a lot of data and graph it, this data graphing and export system, I can send out this link here if you guys are interested in grabbing Great Bay data, yeah, or data from any reserve around the country.
Is that just on the NOAA site?
I don't.
No, that's a little bit different. You can get to this site from this, and we'll send you those websites as well.
Yeah. This is another forgettable acronym, CDMO, Centralized Data Management Office. We basically South Carolina, a place in South Carolina houses all our data. So this is, I'm not going to go with the data graphing export system, but it's pretty intuitive. I'm going to do real time, which if you want to look at real time stuff, should be pretty simple.
Chris, I just want to interrupt you while you're navigating that. What he just said he wasn't going to go into is an awesome place to go because because it's just something that you can really use with your teachers. So spend some time because you can really map some different parameters onto each other and look at every reserve in the nation. So it's pretty interesting. I'll send those to you, so don't worry about them.
Poor Kelsey here doesn't have a good browser. Wasn't even able to open it up. Okay. Chrome, yeah, I gotta go to Chrome, or it just defaulted to Internet Explorer. But anyways, this is the site here, and it has all our stations, and they're all, the acronyms are crazy. So the first 3 letters are reserve, and ACE Basin is, I don't even know what it stands for. Some 3 river names that are, I don't know how to pronounce it, but and then usually the next 2 letters are the site. I'll actually use ours as an example, so I'm gonna navigate there. So Great Bay, GRB is our 3-letter code for Great Bay, and then GL is Greenland, and MET is meteorological. So we'll jump there. And let's do English units for the sake of our brains and lack of conversions. And you can kind of see that it jumped to like 9 degrees yesterday, and then it dropped down to a whopping 74 degrees for nighttime sleeping. It's going to jump back up probably to 90 plus today. We have a suite of other parameters from relative humidity, barometric pressure, wind speed, direction, PAR, which is light, precipitation. So that's a weather station. Nuts. And then I wanted to jump into a water quality station. So unfortunately ours are recording, but they're not real time, which needs to have like a solar panel for battery or for power, and then a satellite transmission. So it's a little bit complicated, especially when we're in the water, but we're hoping to get those up and running for next year. So we're going to jump to our neighbors to the north in Wells, which is at the bottom, and let's go to the Inner Harbor. So Wells, Inner Harbor water quality. So WQ is water quality. So it's the SOND. And we'll use English units again. Sorry if I'm going fast. I realize this is my speed and I know this site very well. Yeah, so this is water temperature now. So definitely not as hot. Real-time data. Probably like, when I say real-time, I'm talking like 30 to 60 minute delay just for satellite transmission, and then boosting it up to the web from our South Carolina office. Specific connectivity, salinity, which has got a tidal effect and a rain effect. Geo, which is dissolved oxygen, definitely has a day effect with photosynthesis during the day and respiration during the night. This is actually tides, so kind of just wanted to walk you through that. Do you have any? Yeah, do you have a question, Stephanie?
Yeah. So as you're going through that, I'm more or less following you with that. If I was going through that with students, I would want students to be able to explore that data and try to understand it a little bit for themselves before I do that. Is there anything that goes along with this that would give them some information that they could try to interpret what that data means before I explain it to them?
Interpret in terms of like.
In other words, they're looking at this, how do they know what that information means?
I can answer that, okay, unless you want to.
Go for it, yeah.
So coast.noaa.gov is the site that we'll send to you, but is the site that you can go to get Estuaries 101, which is a curriculum that has all of this data incorporated into activities. So for example, the Jubilee that Chris talked about uses the actual graph that shows what happened during that Jubilee. So So you can go through some activities first with your kids to say, oh, okay, interpret why did this happen, and then you can.
So you need the lesson before looking
Yeah,
at
it might
the
make
data.
more sense, and so do the lessons, a couple of those first, make, you know, you can point them right to the graph, that's gonna give them that treasure hunt to find out what happened. And then you can say, all right, you know, pick Hurricane Harvey, pick Mother's Day flood, pick these events around, you know, that they witnessed in their lives, and have them actually go to the site and look at, and, you know, each child can, you know, make their own project out of an event, another event. But I think doing the activities first would give them an idea of what they're
Well,
looking
and I know they keep updating that Stories 101 and the small data keeps looking different. So
It does.
It's really good to see that they've added so much.
Yeah, and that graphic export tool is really good now.
Mhm.
Very
It's much
fast,
better.
and, yeah, and actually works, so.
No, I think I've broken it. Yeah, I have the video playing on this desktop and this is stuck on here. But anyways, if everyone saw like a second of the video,
That was awesome.
that was awesome, yeah. That was it. It was a half a second long. But thanks, Kelly. This technology escapes me.